What's up, mathletes? Welcome to Chapter 1, Section 2, Linearity, Intercepts, and Symmetry. Say that with me. Linearity. How does that sound? Right. Linearity, intercepts, and symmetry. So what is a linear function? Well, you can look on a graph. It's a straight graph. You see all these green lines are all straight. Nonlinear would be any kind of curve. If you're looking at just the equation, then it's written as, or the rule that predicts what kind of function it would be. It would just have an mx plus b, slope times an x plus a y-intercept. And if you're looking at a table, then it shows a constant change. So if you take the change in y over the change in x, like that's 2 divided by 1, 2 divided by 1, 2 divided by 1, it's always going to be 2. The slope here for this table is 2. And you can see actually it's 2x, the function that created this is 2x plus 1. Anyway, if there's a constant change then on the table, then you know it's going to be a straight line. Here's what it looks like on alex.com. You can see here these 2 points. The graph, straight graph, yes, linear. Here it goes plus 3, plus 3, plus 3, plus 3 every time, and this is all plus 1. So the slope is going to be 3, and it shows constant change. Yes, function. Here, y equals mx plus b. M is 5. So therefore, yes, it is a function. And if you've got a slope of negative 2 and a y-intercept of 5, that would be like y equals negative 2x plus 5. This is, bread and butter Algebra 1 stuff. I hope you don't mind me going a little fast because I don't want the video to take forever. If this is new to you, then see me and we'll talk it through. As always, please write your questions at the bottom if you have any. Here's a whole bunch of different functions: the f function, g function, the h function, j function. Here you can, and I've written in the table what the slope and the y-intercept is. I know that the slope is 3, the y-intercept is 2. 3, 2. The slope is negative 0.4, and the y-intercept isn't explicitly written. But basically, you could rewrite the g function as this right here, plus 0 at the end, and that's the y-intercept. H of x is equal to 7. That kind of means the same thing as 0x plus 7. It doesn't matter what the value of x is, you multiply it by 0, and you get 7. 7 is always the output, regardless of the input. That has a slope of 0. And yes, it actually is a straight line, so we'll call it a linear function. And here, I know it kind of doesn't look like it, but if you distribute and manipulate things around so that you turn it into y equals mx plus b form, then that's what it looks like right here. And so yes, the slope is 4 and the y-intercept is 4. It is a linear function. Here are some not linear functions. You can see x squared. All of a sudden, if you're squaring anything, then you're going to start getting curves. 2 divided by x, and it's a fraction, 2 over x. Really fascinating functions, really interesting outputs, but they're not going to give you a straight line. It has to be in the form of y equals mx plus b. Here, x times x minus 1. Well, if you distribute, then you get x times x, which is x squared, and that's over here. That's not linear. Here are 3 counterexamples. These are not linear. They're nonlinear curves. Super fascinating, and we will look into more functions like these later. But for right now, no. Intercepts. If you've taken Algebra 1, I'm sure you've seen what intercepts before, but now that we have curves, notice that you can have multiple x-intercepts or multiple x-intercepts. So, for example, here's an x-intercept. It intercepts the x-axis here at the points negative 3, 0. So one of the x-intercepts is negative 3. Now, notice that the x-intercept, if the question is what is the x-intercept, you report number or numbers. You don't report coordinate locations like negative 3, 0. This is not an x-intercept. This is a point on the graph, and the x-intercept is negative 3. The other x-intercept here is, it should be a positive one. I wonder if I can change it right now. Yeah. Whoop. There, you didn't see what that was. I wonder if you can figure out what the next x-intercept is underneath that red dot. Big surprise. Okay, so next, the y-intercept here, it's along the y-axis. It touches this point, 0, 2, and so therefore the y-intercept is 2. If you got questions, write them down. If you're wondering about the audio check, you should know that in high school, I didn't go to SEH, But in my high school, I played the violin, and I played the trombone, and in college, I played the drums, and I've been singing also. So, any of you out there who are, oh, I was also in drama club. That's how I met my wife in our high school drama, what SEH calls the players. So, yeah, I was involved in pretty much every single performing arts thing that I could get my hands on. And so let me know what kind of clubs and activities you're in. I'd love to hear it. Audio check is a violin, trombone, and drums. Okay, let's talk about symmetry. You flip over the page. You'll see here, this is what's called y-axis reflectional symmetry. This graph can get folded along the y-axis. It's a reflection on either side of the y-axis. Here, it's the same exact thing, except it's x-axis reflectional symmetry. The graph could be folded along the x-axis, and you get they would line up perfectly. Here, it's a little harder to see, but there's something called rotational symmetry. If you like rotate the graph around, and if you like spin your computer around, you'll see it. Or if you just rotate your packet 180 degrees around, you'll see that this has rotational symmetry about the origin. So, hold the origin where it is and spin everything else around 180 degrees. You'll get the exact same copy. Turns out that if it's a function, then we have special names for it. We say that this is an even function, and this is an odd function. This isn't actually a function at all because it fails the vertical line test, so we don't have to worry about this. But here are some examples of even functions. Notice they all have y-axis reflectional symmetry. They all could be folded along the y-axis, and you get exact copies overlapping each other. Here are some odd functions. Notice if you put your finger down on the origin and spin the paper around 180 degrees, you get exact copies of the same graph. Here are functions that are neither even nor odd. They don't have this required symmetry. There's lots of symmetry here in these, but sadly, alas, they're not functions, so they can't be even functions or odd functions. They're just not functions at all. Although there is a ton of symmetry you could talk about. This has y-axis and x-axis and origin rotational symmetry. So I could have put this graph here and here and here as examples, because they do have the symmetry. They're just not functions. So, the even function. Here's what we mean. Here's the definition. The even function is a special kind of function that has y-axis reflectional symmetry, like this parabola. Notice I've got f of x is defined as x squared. So that means the name of the function is f. This is not multiplication, it's the function notation. And the input variable is x. And what you do to find the output, well, you just square it. So 5 times itself is 25, 4 times itself is 16, 3 times itself is 9, 0 times itself is 0, negative 3 times itself is 9, positive 9 because the two negatives cancel out, and so forth, same as up here. Notice that you're going to have y-axis reflectional symmetry. It shows up in the table like this. 0, and then 2 9s, and then 2 16s, and then 2 25s. That is if you were having the same pairing here of 0, then negative 3 and positive 3, negative 4 and positive 4. Graphically, it looks like this, and you can see it is, if you were to fold it along the y-axis, then they would overlap, and they're y-axis reflectional. Now, sometimes it's hard to produce a graph. And anytime you can produce a graph as a means for testing symmetry, like figure out is it symmetrical or is it not, then that's the best and easiest way to do it. But sometimes producing a graph is incredibly difficult, even for computers. There's plenty of functions out there that computers just can't produce a graph for. So we need a test that will work for the function rules as it is here. Here's the even test, and this is actually the mathematical definition. If f of negative x is equal to f of x, then f is an even function. Now you probably didn't consider a whole lot about what it would look like to take not just a number to put into this function, like you see here, we're putting numbers into the function and getting outputs out. But you can also put variables in. So what does it mean to put negative x in here into the function? Well, I mean, if you had f of 5, then this would be 5 squared is 25. If you had 10, this would be 10 squared is 100. Well, if you have negative x, then the output is going to be negative x times itself. Now the negatives are going to cancel out, and you're just left with x squared. So if you do the substitution, if you took negative x into the function, and if you simplify it, then you notice we're going to get the same thing here as we do here. F of x is equal to x squared, and then f of negative x is also equal to x squared. And that satisfies this. So yes, it is even. F of negative x is equal to f of positive x. Here's the negative x, and here's f of positive x. And they're equal to each other. So yes, it is an even function. You do the same thing with an absolute value function. If you take the negative version of any input and then you make it absolute value, it's going to be the same thing as just a regular absolute value. So f of negative x simplified is down here, and that's equal to f of positive x, which is up here. They're the same thing. Notice here we've got f of x is equal to square root of 25 minus x squared. This is kind of the first time we're talking about square roots, but it doesn't matter because in order to do the even test algebraically, all you really got to do is take the x, and instead of x, write inside parentheses negative x. And of course, negative x times itself is x squared, as we saw here. So this f of negative x equals f of x in this particular case. Does f of negative x equal f of x? Yes. So therefore, it is an even function. And that's how you can do it algebraically. Odd function. An odd function is a special kind of function that has origin rotational symmetry. We saw that up here, like this. Odd function, odd function, odd function. These are all odd functions. What does it mean exactly? Oh yeah, let's do the equations and tables first. So f of x is equal to 3x. That's the rule. If you have an input of x, then you multiply by 3 to get the output. So here they are. So 5 goes to 15, all the way goes negative 5 goes to negative 15. You notice that you have opposite values repeat on either side of x equals 0. So this is 0, and then you got 9 and negative 9, 12 and negative 12, 15 and negative 15. If you can do that, then you'll see it has the odd rotational symmetry. Like this could get rotated down to here. This bottom point gets rotated up to the top point. So, but sometimes it's difficult to produce a graph, and sometimes it's even more difficult to produce a reliable table. So in that case, if you need to use the algebraic test. If f of negative x is equal to negative f of x, then f is an odd function. What does that mean? Well, let's start with f of x is equal to 3x. If you do have f of x is equal to 3x, let's first work on the left-hand side. We want to figure out what f of negative x is. So you have to put negative x in for x. You notice the parentheses. And so instead of x, you have negative x inside parentheses, and then you multiply it by 3. Simplifying, you get negative 3x. Fine. I wonder if that's equal to negative f of x. What does that mean? Well, here, negative f of x can be replaced with what f of x is equal to. That's 3x. And so negative this is equal to negative of that. And then if you want to remove the parentheses by distributing, you get negative 3x, which is what we got here, too. The left-hand side, f of negative x, is equal to negative f of x down here. They're both the same algebraic quantity. So therefore, it passes the odd test. And yes, it is odd, an odd function, as we verified here, graphically, numerically. Let's take a look. Here's another one. I don't even know exactly what the graph of this would look like. It would probably be pretty steep at the outset. But we don't need to know. Let's do an odd test without looking at the graph. We have to figure out what f of negative x is, and we do that here. Let's take negative x and put it in each time we see an x, put it into the graph. So negative x times itself 3 times will give you negative x cubed, because only 2 of the negatives will cancel out. And then if you get rid of the parentheses here, then you'll see it's just negative x. Plus negative x is the same thing as negative minus x. Getting rid of the parentheses is a great way to simplify these. All right, let's do the next one. What is, on the right-hand side, what is negative f of x? Well, it's negative f of x is equal to negative, and then all of f of x inside parentheses, right here. And if you want to get rid of those parentheses, you have to distribute to both terms on the inside. Now, as I've said before, graphs with x-axis symmetry often aren't even functions because they fail the vertical line test. Fails the vertical line test. Fails the vertical line test. So we don't have to worry about giving them a name like an even function or an odd function because it's not even a function at all. All right, y'all. I hope you have a great day. Thanks for listening, and bring your notes to class and bring your questions too. And that's where I'll see you next. Take care. All right, everybody. Here we are. Go grab your nSpire calculator, and when you've got it, then you can unpause the video and we'll just practice. Here we go. Go on and grab that nSpire calculator. Here it is. All right. So now that you've got it, when you're on the home screen, go to B graph, and here we have the graph. We're going to type in another function. We're just doing lots of equation table graph and the different ways of having fun with that. We're going to go tab and then x squared, enter, and let's change some settings. Menu. We're on the graph now. It looks different. These are the settings for the graph, not the table. We're going to go to 7, table, split screen. That's just one more way of doing Control T. And then menu 2. Edit table. And then going down, 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 down. Let's ask what independent variables we want to input. Enter, enter, enter. All right. So the table is blank. It's asking us what do you want as your input. And kind of like yesterday, we've got 5. 5 squared is 25. Great. Let's do pi. Pi squared is 9.8696. Enter. Let's do something really wacky, like negative x. Negative x times itself is x squared. Ooh, it can even do expressions. Negative 3a. Negative 3a times itself is positive 9a squared. Wow, calculator, you can do a lot. All right, enough of this foolishness. Let's go to let's click on the graph, and now that we're select, you can see now the table is no longer highlighted, the graph is highlighted. We're going to tab up, and we're going to, and now that we're editing a function 1, you can delete, and now we just have x. Let's exponent to the 3rd power. This is now x cubed. And now notice the table changes. Negative 3a times itself 3 times is negative 27a cubed. Ooh, fancy. Control T hides the table. We're just cleaning up at this point. Tab, let's delete. Don't delete the equal sign. And then enter, and now we've got a clean graph ready for the next thing. On gets us to the home screen. That's it. See you tomorrow.